Hi there, welcome to this calculus tutorial. Today we're going to try and find the area bounded by two curves. So the example here says determine the area bounded by y equals 2x squared plus 10 and y equals 4x plus 16. So the first step is to find where these two intersect. And we do that by setting them equal to each other. So 2x squared plus 10 equals 4x plus 16. When I move things over to the other side, I end up getting 2x squared minus 4x minus 6 equals 0. And then I can go ahead and I can factor out a 2. They each have a 2 in common. And when I do that, I'm left then with x squared minus 2x minus 3 equals 0 once I've divided both sides by 2. And now we're at the point where we can factor. And so what would this factor out to? Well, we end up getting x minus 3 and x plus 1. So therefore, we have x equals 3 and x equals negative 1. When I plug 3 and negative 1 into either one of my original equations, I get the point 3, 28, and the other point is negative 1 and 12. So these are the points of intersection. So the next thing I'll do is draw a picture. So in this, I have something that looks like this. And if you have a graphing calculator or a website where you can go to graph, this will make it easier, but it's not necessary. So I end up having negative 1, and then 1, 2, 3. And up here, let's say I have 30, 20, and 10. So I've created my scale. So my first point of intersection is at 3 and 28. So maybe something like that. And the next one is at negative 1 and 12. So I know that my region will be somewhere between these 2 points. So let's go ahead and graph the first one. And I'll do this one, say in pink. And so this one is a parabola that's shifted up by 10, and then it will go through my 2 points of intersection. And then my other one, let me do this one in green, is a linear function. So that'll be a straight line between these 2 points. Now this isn't drawn perfectly to scale, but at least I have a general idea of what I'm doing. And then my area is what they said is bounded or enclosed by these 2 points. So like we said, this is the point negative 1, 12, and this is the point 3, 28. And the last thing I'll do is I'll label each of my functions. So this bottom one, my lower, was the 2x squared plus 10, and then my other one, my top or my upper function, is the linear one, the 4x plus 16. So now let's proceed. You may have noticed some notes that I've made over here on the right side. So when we have something that has an upper and a lower bound, we want to use integration according to x. When we have something that looks like it's maybe a right and a left, we would then want to integrate with respect to y. And so looking at our picture, it is clear to us that this is an upper and a lower function. We have an upper and a lower, not a left and right. And so we want to leave these equations in terms of x, which they already are. And then we follow this formula as shown. So it says the area is from a to b, f of x being our upper function, minus g of x being our lower function, dx. So my a and my b are over here. This is my a, and 3 is my b. So when I go through, I can plug this in. I have the integral from negative 1 to 3. F of x is my upper function, which in this case is 4x plus 16. And g of x is my lower function, which is 2x squared plus 10. Now it's imperative that you keep parentheses at least around this second term, because the next step is to distribute this negative sign before we can go any farther. And when I do that, I get negative 2x squared minus 10. And then from here, let me rearrange and simplify things just a little bit. I end up getting negative 2x squared plus 4x plus 6. Now I'm ready to take the integral. And when I do that, I end up getting negative 2/3 x cubed plus 4/2 or 2x squared plus 6x, and we're integrating from negative 1 to 3. When I plug all that in, as we know how to do, I get 18 minus a negative 10 thirds, or when I convert that to a common denominator, I get 54 thirds plus 10 thirds, or a final answer of 64 thirds. A lot of work to find one simple area, huh? But it's the same process each and every time. Step 1, figure out the points of intersection. Step 2, draw those points of intersection along with your graphs. Step 3, determine if it's an upper-lower area or a left and right area. And step 4 is to plug it into the correct formula and do your integral. And there you have it. You have the area. 64 thirds is what's bounded between these two curves. So try some similar problems like this on your own. Good luck!